Hey hackers, welcome to Azefox Innovation's new video on OS command injection. OS command injection, it's a vulnerability which occurs when an application takes user's input and executes it directly as system commands on the server. In simple terms, it allows an attacker to treat the server like their personal terminal. With this flaw, attackers can run arbitrary commands like ls to list files, cat to read sensitive information, or even whoami to discover which user the application is running as. Ultimately, this kind of issue can escalate into complete remote code execution, giving an attacker full control over the server. Now OS command injection, it usually comes in two forms. The first is the direct injection, right, where the attackers append malicious commands using operators like semicolon or like double ampersand or a pipe, right, etc. Then the second form, the second form of OS command injection is called blind injection, where no input is directly where no output is directly shown to the attacker. Instead, they confirm successful exploitation, using techniques like adding time delays with a command such as ping -c or hyphen c10, or by exfiltrating data through DNS request to a server, no server the attacker controls. As we know, like as we have a bit knowledge on what is OS command injection, of course the people might be into a question like, but where do this vulnerability shows up, right? So OS command injection, often found in common input points like web forms, right? Or for instance like on search boxes or feedback fields, in file upload features, in URL parameters, like or even in HTTP headers such as user agent or referrer. Essentially, any place where input is taken and passed it to the system shell is a potential entry point for injection. Some of the common vulnerable functions, which actually leads to command injection, right? The real danger actually lies in developers, using unsafe functions that directly execute system commands, right? In PHP, functions like system exec or shell exec are commonly abused. In Python, the misuse of the os.system and subprocess.popen, right? Where which shell is equal to is like really risky. Similarly, in Java applications that call runtime.get runtime or .exec, right? Or in C programs we use a system or popen things. And also in Perl we have a system or backticks for command execution. Like literally these functions are really dangerous, and if any if any developer is using this code into your application, right, then the application can be vulnerable to OS command injection without any doubt. So here's a quick vulnerable example in PHP, right? Imagine a developer writes code like this, right? So here what happens, like here if a user submits a normal IP, right, the system just pings it, but an attacker could enter something like 127.0.0.1, or to be precise localhost. Then we can use a semicolon and cat slash etc slash password, right? And suddenly the application would expose sensitive system files here. So some of the real world impacts of OS command injection, right? So this is not just a theoretical problem; it has happened in the real world also. For example, in 2020, a bug was found in GitHub Actions that allowed OS command injection in CI/CD workflows, right? Another famous case for OS command injection is CV 2021 4034, which is also known as PoundKit, which was a local privilege escalation bug in Linux fault kit caused by improper command handling, right? These cases shows like how widespread and dangerous this vulnerability can be. I would say that OS command injection is like it's not only limited to web applications. You can even find them in real world software on real world operating systems, right? And if you're able to find an command injection vulnerability, you can directly execute arbitrary code on any operating system itself, right? So that's what that's what makes OS command injection one of the most deadliest one among all the other all the other vulnerabilities. So yeah, now we are in the action part. We are a small demonstration here about exploiting OS command injections, right? So for lab, I'm going to use the port trigger lab. Definitely, for just this video, I'm using the direct injection part, like directly executing or directly exploiting the normal OS command injection one. In the upcoming videos, definitely will focus on the blind injection part, like exploitation of the blind OS command injection too, right? So if we read the lab description, what it says, like the lab contains an OS command injection vulnerability in the product stock checker. Okay, so the application executes a shell command contained. Okay, and to solve the lab, to solve the lab, execute the whoami command to determine the name of the current user. Okay, so it says that the vulnerability actually lies in the product stock checker, right? So we need to check for this particular functionality. So let me just go to the view details part here of the first product. And you can see we have an option here, a functionality known as check stock, as what mentioned in the lab description, right? So if no if our guess is right, here where the actual vulnerability may arise, right? So to test this, what I'm going to do is I'm just going to use my burp suit here, right? So I'm just going to turn on the proxy, and let me just check the stock here, and I got the request, and let me send this to repeater. Okay, and yeah, so as you can see, we have two parameters here, right? So either the voice command injection, we can test either in this parameter or in this parameter, right? So let's try in this one, first one. So as like the main agenda or the main concept over here is that, like, whatever the input you give, let's say this checking feature, right? This check stock. What it does, if you click on this, it will directly check at the level of operating system, right? We know that generally websites are hosted in servers, and servers are generally Linux and built in Linux. Okay, so if I click on here check stock, what actually happens behind the scenes is that it will actually and actually it executes the stuff at the operating system level, right? At the OS level, using any sort of vulnerable functions as we saw in the slides, right? So what happens here, if you give any sort of input, it will directly check that by actually executing the command in the operating system shell. Okay, so this is what the main concept of this vulnerability is all about, and also for this lab. So as you people, like, if you're familiar with in Linux, you people know that how you can actually execute two commands in a, like, how I can say, like, two things in a single command, right? um, for just a small quick demonstration, not a demonstration, for an example purpose. Wait, wait. So as you people know that in Linux, if you want to list any files, for an example, you can see ls, and it will list you all the file. Okay. So what if you need to also execute another command, parallelly along with this, with this command ls. So for this, you can actually use various operators, that's been given by the operating system. In Linux, we can actually do this using the ampersand, the ampersand operator, or by using the or operator, right? Sorry, the or operator, right? So it's not an or, but it's a pipe. It's called a pipe. Okay, so a pipe operator, etc. So for this purpose, like, we can use and, then we can use cat none.txt, right? So what it does, it actually executes both the command at the same time. It will execute ls, like list the files, and also give you the contents for non.txt. It displays you the content for non.txt, right? So likewise here also, if we need to execute any sort of command here, we also need to send the product ID, or the number, along with the along with our malicious command, right? So let's first send this normally, and let's check this. So here you can see that it's 62, the product ID is. So it's not the ID, it's about the available stocks for this one. So let me remove this and let me put ls here. Will it work? Let me check. 16. Okay, so like it's not properly working. It's not like actually displaying me the content. Okay. So now what I'm gonna do here is I'm gonna one, right? Then use ls. Wait, also use semicolon here. Let me check. Okay, so it says it's not able. Oh, I guess that's an issue. Okay, it says and an unbound variable. Okay, so now we can check with the store ID part using the same command here. And as you can see, we were successfully able to execute arbitrary commands on the server, right? So it is actually displaying the files that's been inside the directory where the application is actually hosted, right? So as per the lab description, we need to use the command whoami to solve the lab, right? And you can see that the username is Peter, right? And if we want, we can also list out the etc password. As you can see, we were actually able to execute commands on the remote systems, right? So this is like one of the example, right? For the other demonstration part, I'm going to use DVWA. DVWA is like something known as Diamond, no, vulnerable web application, right? So it actually contains, a lot of, vulnerable, web application vulnerabilities, right? Where you can actually test and practice of the things, right? So again, here you can see in the command injection part, here it says that enter an IP address to ping a device. Okay. So let me just, enter the normal, the loopback address, right? So if I submit this, okay, it says that it's actually pinging and we are getting a reply. Okay. So again, now we will try to test for command injection vulnerability here. Let's again put ls, a basic command. Will it work? Okay, nothing. So how about like again putting our IP address here and thereby executing the command too. And okay, as you can see, we were able to list the files here, right? We were actually able to list the files here using the ls command once again, right? So again, let's try to dump the cat etc password file, right? And just a pipe this time, and cat etc password, and let me submit this. Okay, it's loading, and yeah, as you can see, again we were able to list out the the etc slash password file contents here, right? So this proves like how dangerous the file the OS command injection is, right? So back to the slides now. So the prevention and mitigation. So the first term, is like input validation, like only allow expected values and reject everything else, right? Next, the developer should avoid system calls altogether when possible, and use safe APIs instead. So if system calls are absolutely necessary, then sanitize user input to strip out dangerous characters. And applications should also follow the principle of least privilege, meaning they should run with minimal permissions. So even if an injection happens, the damage is limited, right? And finally, monitoring and WAPs. WAPs actually stand for Web Application Firewall, right? Which can actually help us to detect suspicious command execution attempts before they succeeded. Okay, so yeah, in short, or the conclusion or part of this is like OS command action is one of the most deadliest vulnerability because it actually turns a small coding mistake into complete system compromise, right? So yeah, but even like with careful coding practices, validation, and security layers, developers can keep their application safe from it. Okay, so now the direct, or the normal OS command injection part is done. Now, in one of the upcoming videos, we'll also explore the blind OS command injection too, right? So yeah, that's all for this video. We'll catch you all in another new video. And make sure you follow and subscribe Azefox Innovations for more informative videos. Bye.